So let's take a look. We've encoded our finite state machine, made a present state, next state table. We created our implicant chart, and now we're going to take a look and see if the outputs are different as we compare one row against another. So A is different from B, D, G, and I. B, D, G, and I. B, D, G, I. Yep. Then B is different from C, E, F, and H. C, E, F, and H. And then C is different from D, G, and I. D, G, I. Now D must be different from E, F, and H. E must be different from G and I. F must be different from G and I. G must be different from H. H must be different from I. A very sparsely held matrix showing a number of states that are not equivalent to others. So that's kind of interesting. That's not bad. Let's look at AC. A is equivalent to C if A is equal to F. We don't know about that. It also requires B equal G. Now let's take a look at some of these things it depends on. A is equal to F if A equals H. And if B is equal to I. And B is equal to G if C equals C, and it does, and if E equals F. So I went deep into it. I said BG, and BG is here. And we know that BG requires C to be equal to C, which it does, and then E equals F. So that's not too bad. Let's take a look at EF. E equals F if H equals I. H does not equal I, so E does not equal F. Since E doesn't equal F, then B doesn't equal G. Since B doesn't equal G, then A doesn't equal C. And if A, well, I guess that's where we stop. We know that A equals F if A equals H. We don't know about A and H. And if B, yes. I lost you? Okay. What we wanted to do was we wanted to find out what was dependent on what. Once we determined that see here, E and F has an X. So E is not equal to F. And what we knew from B and G was that C had to be equal to C, and that's okay, but also that E had to be equal to F. Since E does not equal F, I can say that B does not equal G. Well, if B doesn't equal G, then I also know that A cannot equal C, because A only equals C if B equals G. So I got another X in here. So one thing dependent on the other, you see. And so everything was based on this idea that B might be equal to G. We went down to BG and we said, hey, yeah, that works if E equals F. Then we went to EF and we said, hey, wait a minute, there's an X there. E doesn't equal F. Therefore, B doesn't equal G. Therefore, A does not equal C because A equals C requires that B equal G. How's that grab you? Sure. So then A equals E if A equals I, and it doesn't. And I was looking at A in F. A in F said that A had to be equal to H. We don't know about that. And that B had to be equal to I, and we don't know about that. Let's take a look at that AH. A is equal to H if A equals F. So isn't that interesting? A equals F. And A is going to be equal to H if B equals B. So AH is true if A equals F. AF is true if A equals H. If only we knew more about BI. So BI says that C has to be equal to C, and E has to be equal to E, and they are. So B equals I. They're equivalent. In fact, I'm so happy that they're equivalent, I'm going to put a green check mark in there because look how happy I am. And now, if I know that B is equal to I, and then it must be the case that if A equals F, if A equals H, and A equals H, if A equals F, that these two things are in a cluster, and they show equivalences. All right, get my green check mark in there too. There's green. So now I have A equals H, which is really cool. And I have A equals F. That's really, really cool. So now I've got a couple of equivalencies, and that's actually simplifying things somewhat. Let's take a look at this B and D. B equals D if C equals C, that's good. And if A is equal to E, but it's not. C is equal to E if F equals I. It doesn't. That's no good. Let's see. C equals F if F is equal to H. It might. C equals F if G equals I. It might. Let's take a look at that F and H. F is equal to H if F equals H. That's pretty good. And if B is equal to I, hey, F equals H. Oh, I gotta get the green in there. F equals H. That's nice. So now I got, oh, and we know it equals H, right, because of this. And now I have, does G equal I? Because I needed that from up here. And let's take a look. C equals C, that's right. Does F equal E? It does not, because look, there's an X. Since F doesn't equal E, G does not equal I. If G doesn't equal I, then that means C does not equal F, because C, F goes to GI. And that's no good. I was getting my hopes up. What about C and H? C and H, I got F and F, that's good. I got B and G. Uh-oh, that's no good. So I'm going to cross that out. How about D and G? I think we just did that, didn't we? D and G, that's C and C, A and F. Oh, D and G, that works. D and G works because C equals C and because A equals F. So D equals G. I'm going to get my green. D equals G. D equals G. Very cool. And now let's see if we can look at D and I. So D is equal to I if C equals C. That's good. And if A is equal to E, A does not equal E, right? Because we've got an X here. So that's got an X. How about E and H? E equals H if I equals F. It does not. And so now I got my equivalencies. And so what that tells me is anywhere I see a G, I can write a D. anywhere I see an H or an F, I can write an A. Anywhere I see an I can write a B. And now we're down to 1, 2, 3, 4, 5 states. A, B, C, D, E. And yeah, that's what I see. And it's got to show A, B, C, E, A, D, C, A, B, D, it says. B, D. And outputs are supposed to be 1, 0, 1, 0, 1, 0. 1, 0, 1, 0, 1. Is there another one? 1, 0, 1, 0, 1. 1, 0, 1, 0, 1. Yes, that's what we got. It's my answer right there. So what do you think? That's challenging, right? I got the answer, though. I know it's not much, but it's all I've got. So there it is. Problem number 2 from homework 12. Are there any questions about what I did here? This was, well, getting progressively harder. And they're getting harder still. They're getting harder still. Right? Because the next one is going to blow your mind. How many minutes do we have left on this? Oh, we have time. We got half an hour. Great. That's great. Let's see. What do we got here? Ooh, baby. I like this. Look at that. Look at this. What's going on? What is he writing? What does it mean? How do we understand this? Well, now our finite state machine has 2 inputs, x and y. We've never seen that before. Tricky. So now, with 2 inputs on the finite state machine and 2 variables, I have to have, well, twice as many arcs. I have to have at least an arc for 0, an arc for, well, I have to have 4 arcs for each state. 4 arcs for each state. So in other words, A has departures for 0, 0, 0, 1, 1, 0, and 1, 1. When you start adding variables, you basically start adding arcs. And in fact, if it's 1 variable, you need 2 exits. If it's 2 variables, you need 4. If it's 3 variables, you need 8 exits, 8 arcs. By that time, you should be using a computer program like Quartus to do your optimization for you. But we can still do these by hand. What I shall do, however, is get a clean piece of paper, and I am going to write out the present state, next state table so that we can work with it right off the graph paper instead of having to work with it off the homework. So we'll write the present state, and it's A, B, C, D, E, F. And then what we'll do is we'll write the next state with x, y equal 0, 0, 0, 1, 1, 1, and 1, 0. Notice I didn't write xy equals 0, 0, xy equals 0, 1. It just gets so... Wait a minute. Yeah, it's so tedious if you do it that way. And then so this actually is gray code. That's the way it's listed in the problem, so I'm going to leave it that way. And then A, C, E, D, D, E, E, A, E, A, F, B, BCCB, CDFA, FBAD, and the outputs zero zero 1011. And that is what it says on the paper. Let me just say that this is an E. You know, it's my handwriting, and it gets sloppy sometimes. That's an E. And then underneath it, it's also an E. There. And that's supposed to be an A. And I think I've written this right. I want to make sure. So you guys check me. If you have the homework in front of you, check me, make sure it's right. So what's my first step? Well, I can't do any row matching here. None of these rows look alike to me. I think I've got to do an implicant chart. Have to. So let's do it. We'll start with B and work our way to F. And then we'll start with A and work our way to E. Now we're going to do the same exact thing we did before. We're going to compare outputs. So A is different from C, E, and F. B is different from C, E, and F. C is different from D. D is different from E and F. And E and F might be the same, so we don't know. So we've got a relatively sparse set of possible combinations to do comparisons on. Let's see if we can figure this out. So A to B requires that A equal D. It requires that C equal E. It requires that E equal E, that's okay, and that A is equal to D. We got that already. So now let's take a look at AD, which is here. A is equal to D if A equals B. A equals D if C equals C, that's good. If C is equal to E, A is equal to D if C is equal to E, and if B is equal to D. That's a D right there. So we've got a bunch of conditionals there on A and D. Let's see if B is equal to D. So B is equal to D if B equals D, that's good. If C is equal to E, B equals D if C equals E, C equals E, and A equals B. Let's see if, so I needed AD, I needed CE. We didn't look at CE yet. Let's look at CE. So CE is good if C equals E, that's right. If A is equal to D, so C equals E if E equals C, A equals D, F equals F, and A equals B. So A equals B if A equals D, and C equals E. A equals D if A equals B, and C equals E, and B equals D. Wow. B equals D if C equals E, and A equals B. C equals E if A equals D, and A equals B. So they're all in a cluster. And so I say they're all equal, and I can put check marks in them all. They're all interdependent, and we can treat them all as a cluster. So that means A is equivalent to B and is equivalent to D, and that B is equivalent to D, because that's what that says, and that C is equivalent to E. And now I can check it out and ask if C is equivalent to F. Yes. Well, I knew that A was equal to B if A was equal to D and C was equal to E. And I knew that A was equal to D if A was equal to B, C was equal to E, and B was equal to D. And I knew that C was equal to E if A was equal to B and A was equal to D. And I also knew that B was equal to D if C was equal to E and A was equal to B. So what we had was a whole bunch of interdependencies on one another, and they all grouped together into a single cluster. So essentially, one was pointing to the other, which was pointing back to the other. So I put check marks in everything because that ended up being a cluster. Right? Because this guy depended on that guy. That guy depended on this guy. So if they depend on each other, they're equivalent. Right? So AB depends on AD. AD depends on AB. Right? So they're interdependent. And then CE depended on AD and AB, and AD depended on CE, BD, and AB. So they all ended up becoming a cluster together because of the interrelations. Well, we didn't, when we put the check marks in, we saw that A was equivalent to D, and we saw A was equivalent to B. So we wrote that. We also saw that B was equivalent to D, but that we knew. And we also saw that C was equivalent to E, but that doesn't necessarily mean that they're equivalent to A. It just means it depends on it. It may be after we finish exploring these other squares. Does that sort of answer your question? Okay. So then C and F requires that E be equal to F, which it is. C and F requires that A be equal to B, which it is. That A is equal to F, but it's not, you see. So then this is not equivalent because A does not equal F. And then I have to look at E and F. That's true if C is equal to F, and it's not. So what I'm left with is here. That's what I got. And so what I do is I cross out E, and everywhere I see E, I can write in C. I cross out D and B, and everywhere I see D, I write in B. And everywhere I see D or B, I write in A. I think that's it. So this is FAAA on row F. Check it out. F AAA, row F with an output of 1, right, just like that. This should be CAFA. What do we got here? E was supposed to be C. So everywhere you saw C or an E, you're supposed to put in a C. So that's supposed to be CAFA, CAFA, that's cool. Then ACCA, ACCA. It works. There's your answer. Looks just like that. Only this is neat, and that looks like slop. But it's correct. So there. What do you think of that one? As someone said, it's a blast. So this was homework number 12, problem 2. Jeez, how many? No, problem 3. Sorry, problem 3. So we did 3 problems? These things take a while, don't they? So, fun. Very fun. Let's see. We're burning through these, aren't we? Halfway through this homework almost. Let's see. We need problem number 4. Where would I be if I were problem 4? Oh boy. Oh, you're going to love this one. Okay, well, it is what it is. What can I say? Yep, there you go. Ha! Not to be outdone, let's add some more letters. Because, what the hey? Did I mention these problems get progressively harder? So, yeah, they do. It's true. Let's start from scratch on this one because I think it makes sense to rewrite the whole thing so that we can manipulate with it. So what we're doing, what are we doing? I don't know what I'm doing. Here's what we're doing. We're doing number 12, homework 12, problem number 4. How's the focus on this? Is this focused okay? Guess it looks all right. Not to put too fine a point on it. Wonder if I should try and focus this, or if I'm going to screw it all up. I hate to mess with it because it seems to be working. It's not too out of focus for people, is it? Everybody's okay with this? I'll just proceed. I'm going to hit the focus button and see what happens. Nothing. Ah, how about that? I think Zoom took over. Alright, I'm not going to try and mess with this camera because we're in the middle of something here. So let's do this. I'm going to go to problem number 4, and I'm going to write the present state, next state diagram. Present state, next state, output. And the next state is going to have xy 0, 0, 0, 1, 1, 1, 1, 0. That's the present state. And it's lettered A through K. A, B, C, D, E, F, G, H, I, J, K. Okay, that's enough. Just keep adding more letters here. And why should we stop at K? Let's go down to Z, because that's even more funner. So now, BICG, BCFG, HDDF, HCEG, BCIG, FIIK, JKHG, EFCG, IIID, BFCG, ACEG, you know, I do this in pen for readability, but you might feel better if you did it in pencil. So anyway, 0, 0, 1, 1, and then it's all zeros until you get to the end. And that is how you do that. Hopefully I got that right. I'm just copying it from the paper so that you can all see it. Let's see. What do we do? What do we do? I don't see any row minimization. Just sort of scanning it real quick to see if we can reduce it. And I don't think we can. So we're going to have to do the implicant chart. B, C, D, E, F, G, H, I, J, K, no. And now we write out A through J. A, B, C, D, H, I, J. Okay, enough of that. And now it's time for the implicant chart, the lower triangular matrix. I do like the graph paper, although I could see reformatting it so the little squares are kind of bigger. But so far I've been able to cope without it. But if you look at the cat's book, he's actually writing all the links inside of each square, which is really impossible if you're going to make tiny little squares like this, because it won't be readable. So now let's take a look at the outputs. A is different from C, D, and K. B is different from C, D, and K. C is different from E through J. D is different from E through J. E is different from K. F, G, H, I, and J, all different from K. And that's what we got for our output matrix. Unless I've made a mistake. Does it look all right to everybody? Any errors? All right, let's see what we can do in the remaining time. So does A equal B? Yes, if B equals B. And if C is equal to I, it does not. Does A equal E? Well, A equals E if B equals B, and if C is equal to I, it does not. A does not equal E because C does not equal I. Here's C, there's I, doesn't equal, that's it. A equals F if B equals F. We don't know about that. If I equals I, yes. If C equals I, no, it doesn't. A equals G if B equals J. We don't know about that. If I equals K, it does not. A equals H if B equals E, it might. If F equals I, it might. If C equals C, it does. If G equals G. So we've got a couple of dependencies here on A and H. Let's go to the next one. A and I is true if B is equal to I. Might be. If I is equal to I, if C is equal to I, wait, it doesn't. C does not equal I. so A does not equal I. A equals J. A equals J. B equals B. If I equals F. If C equals C. If G equals G. You know, that might work. So it's really all about I equal F. I is going to be equal to F if I equals F, if I equals I, if I equals I, if K equals D. K might be equal to D, so I might be equal to F. K is equal to D. Let's take a look at K and D. KD is true if A equals H, if C equals C, if E equals E, if G equals G, and 1 equals 1. So KD is true if A equals H. So let's take a look at that. A is equal to H if B equals E, if F equals I, if C equals C and G equals G. You know what? We might have a nice little cluster there. So we'll come back to that. Let's keep going. So what's going to happen here is we're going to keep running through these matrices and look for interdependence. So for AH, for example, if I see I need BE, I would go in here and write it. AH requires FI. BE, we haven't done yet. BE needs B equal to B, C equals C, F equals I, and G equals G. So BE is really all about FI. And AH is all about FI and BE. And have we looked at FI yet? FI requires KD. And what does KD need? Well, KD needs AH, and AH needs BE, FI. You know what? I got a little cluster right in through here, so that's pretty cool. That's a real good cluster. And so A can be equal to J because B equals B, F equals I, if F and I are equal. And so I got all of these interesting sort of things in my cluster. I'm going to put check marks in them all. And now I can write it out. A is equivalent to J. Got another one here. And is equivalent to H. I got B is equivalent to E. I got D is equivalent to K. I got F is equivalent to I. That's a lot of equivalencies, and I can keep going. And I still have another couple minutes, so I can perhaps make some more headway here. I won't finish it, I don't think. B goes to F if B goes to F, C goes to I. Do we know if C is equal to I? It's not. So that means B is not equivalent to F. How about B and G? B is equal to G if B equals F. B does not equal F, so B does not equal G. If B is equal to H, B equals H if B equals E. B does equal E. And if C is equal to F, but C does not equal F, therefore an X. B goes to I if B goes to I, if C goes to I, and C does not go to I, so that gets an X. B goes to J, B goes to J, B goes to B, if C goes to F, well, I think we know C does not go to F. And how about C and K? C goes to K, if A goes to H, and it does, if C goes to D, and it might, and if D goes to E, and it doesn't, because D does not go to E. And now C and D. C and D, HH, CD, DE. Oh, that gets an X. How am I doing on time here? Oh, okay, I got part of a minute. E goes to F if B goes to F, and it does not. E goes to G if B goes to J, and it does not. E goes to H if B goes to E, and it does. And if C goes to F, and it does not. E goes to I if B goes to I, and it doesn't. E goes to J if B goes to B, if C goes to F, and it doesn't. We're almost done. We're running out of time. 8 seconds to go. I can't finish the rest of this in 8 seconds, but maybe I'll just keep going. F goes to G if F goes to J. You know what? It doesn't make sense to rush it because some people have to go to another class. So what I'm going to do is I'm going to stop here. We'll pick this up from homework number 12, problem 4 next time. That'll be on Monday. Why don't you take a stab at finishing this? I've almost finished it myself. See if you can finish this up, and maybe it'll improve your understanding, because it'll make you tired to watch me do it, but you don't get the benefit unless you do it yourself. So this is what we have so far in terms of our equivalencies. And so we've removed 1, 2, 3, 4, 5 states from this diagram. Let's see if we can remove some more by doing some more inspections. So that's what I have for you for today. Sorry we couldn't finish this last example, but this one's a tough one because it's a little bit long and we needed more time. So thanks very much, and I hope you guys have a nice day. Stay safe. Thank you.